we have to do?
Find the circumference of the tree in the given year. Or
All right.
diameter.
Plan a strategy.
We have to plan our strategy, which includes finding the circumference of the tree in the given year. So in the given year, we're in year 13. Oh, that's cool. And the diameter of that tree is 22.2 inches. Okay? What else do we know about this? It's 45 inches tall. Fabulous. It is 45 inches tall. I'm going to write all over this. That's okay. The diameter is 22.2 inches. The height is 45 inches. All right. So,
you need to know the width of the tree wrap too. And I'm not. Since we're asking for square feet, you need a square measure.
Right. So we're going to be finding the surface area of the cylinder of this tree wrap, right? Does anybody remember what that formula is? So, I should have written this down beforehand because I don't remember it either.
2 pi r h.
2 pi r.
H.
Yep. So that's for the surface area of the cylinder. On the actual formula sheet that the students get, though, it includes how to find the area of the bases of the cylinder.
This is not like any other tree wrap that I have ever seen, by the way.
It is a ridiculous tree wrap, right? It's a ridiculous
So I
tree
was
wrap.
assuming it was the strips that you wrap around, which does in fact protect you from crows. No, this is like a, I don't know,
It's like a tarp or something, yeah.
And the idea that you put it on in the 13th year, okay, I'm not supposed to think like that, right?
Yes, stop that critical thinking, Joyce.
Okay.
So the first step that you have to realize in this problem is that the surface area of this tree wrap takes this formula but cuts out the area of the base because it doesn't have the bases. So that's the first thing. Well, not the first thing. They already had to recognize a lot of things about this problem. But part of their plan is they have to know the formula well enough to be able to eliminate part of it as they solve this problem. There's your first blow my mind moment, right? And then they go ahead and they calculate it. They have to know how to plug it in. They have to recognize that they were given the diameter and convert it to the radius in order to solve the problem. And then Joyce had a good observation. It asks for square feet. What are we given?
Inches.
Inches. So that's another element of this problem. Once you've done all this work, you think you're done, you're so excited, and then you still have to convert this darn thing. And since they're square units, it's not by a conversion factor of 12, it's by a conversion factor of 144, because there are 144 square inches in a square foot. So this problem has a lot of elements that could trip a student up. And it's indicative of a lot of the problems on the new GED test, where it has that level of significant complexity. So, we don't have calculators, so we're not actually going to do the calculation to solve it, but we just wanted to go through some of these steps so that we can see how complex it is. And we're actually going to ask you now to get up and move around and work on figuring out what every single skill in this problem is, because that's going to help us later on as we talk about scaffolding.